Okay. Good. Good. Now I can. Let's see if I can get my other camera working. Oh, this is. Okay.
Hi, Tilo. I see
Hi,
you.
Rudy.
I see you still setting up the.
Yeah, it's the. I'm in the boatyard these days, and
Yeah.
so it's the. Wait a minute. And so this is causing my schedule to all sort of.
And you're now a
up.
happy Amel owner now. I see.
Well, yeah, happy-ish. And why is it not connecting my camera? Camera says it's there.
Keep quiet. So
you got to bring down your camera a little bit, Tilo. I'm only seeing your very nice forehead.
Yeah, my
there you are.
more hairless one, but I have a different camera that I need to get going here.
But you have a beard now.
Yeah, I do. It was sort of it's one of those in the yard, might as well look grungy things. And so, yeah,
Anyway, one question. Do you have a lot of background noise from me?
Nope.
Okay, because I've got the echo running and
yeah, no, I wish I could.
Hi, Eric. No, there's not at all any noise.
Okay, thank you.
No.
Okay. Yeah, I'm going to be in the yard for the next year, so that's not making me so happy. And I will be hoping to get things going here. I found out that, and it was something that wasn't really foreseeable, but the the boat had been in La Rochelle during Martin, and it was a that was a bit of a problem. The things weren't actually repaired properly. Okay, so now my webcam isn't working. Oh, I was going to do a more slightly more I think that's going to just blind me. slightly more active display here. But anyway, so we have, seems a small group. And so I think we're going along here. So anyway, I'm going to introduce myself. Well, you guys all know me. In any case, what I wanted to say about this is that I'm really just sort of getting, I've been doing 3D printing for 12 years, something like that. And I did part of my doctoral research on it, as far as the, how innovation was really stifled by patents, because, and the 3D printing industry is something that's really illustrative of that. So so anyway, that was how I got into this, and then having discovered that there were certainly some issues with the with parts not being available, I really became much more active in 3D printing in order to accommodate that. I think some of you may know that I've been, I did a design for the hold open for the port lights. And then I also just got really angry at the price they were asking for window screens. So I've been, I've done a design for window screens. Anyway, I'll talk a bit more about that. But it's, I haven't really done much in the printing realm for a number of years. I pulled my old printer out that I bought back in 2011 and put it to work, and it burnt out. And then was really amazed when I then went on the search and bought a new printer and found how much better they've become with automatic bed leveling and a whole bunch of other things. So, these are the things that we've seen lately. And it continues to improve, not only as far as the printers and the methodology, but also the knowledge of how printing can be made better, and also the resources that are available. And so what we're planning on doing here is making this a sort of a 3 or a 4-part workshop series. And so tonight, what I'm going to talk about here is, an overview of 3D printing and an overview of 3D printing and the technologies and what it may or may not function on a boat, what can be made with, and with what limitations. Key things to look for, and what I've chosen and why, and my, just a show of what my up and coming projects are. And then in a few weeks or month or whatever, depending on demand, we'll talk about a bit more in depth about materials and uses. And so we'll talk about filaments, build surfaces, adhesion, a whole bunch of things like that. And then part 3 or part 4, depending on how we want to do it, is access to designs and designing. So, I am not a mechanical engineer, so, but I've been doing a lot. I've been doing a lot of fix-it stuff. So, I found a very good program that I can use for designing things. It's not a super pro CAD CAM program, but it really is strongly effective in being able to address that. But the truth is, for most things, you don't generally need to have any designing skills, because I'll show you how you can, get into that without being a super duper designer. So then the different technologies, just to give you an overview of what there are. Three-dimensional printing was invented in the 1980s, with the first patents arriving in 1991. A company called Stratasys was the first mover with a filament-based technology, and that was really, has always been and continues to be the mainstream of 3D printing. Then another company came up just about at the same time with resin printing. And that is, as you might see here, so this is an example of something that I'm actually printing right now on my printer. And then this is an example of a resin printer. It actually prints upside down, has a thin layer of resin that then is selectively heated by infrared lasers. Of course, that would make it difficult for being on a boat, because of the fact that that resin will slosh around and you won't get consistent prints. Even the slightest movement disturbs these printers. So that pretty much is, something. If you feel you need to have something resin printed that's really, really smooth and really has a bit more of a finished look, although the 3D printers of today are so much amazingly better than the ones that I was using, a few years ago. It's really surprising how good the finish is. So, and then the last thing that came into the market was selective laser sintering. And this is this one on the bottom corner here is an example of a 3D sintering machine that's actually made by a Swiss startup that called Sintrex. But what this type of machine is basically, it's a huge powder bath that then has lasers melting that material and sintering it together. And so this is something that is, of course, very messy because there's a huge amount of powder. It is, even for a semi-amateur machine like this one, it has a very high power requirement. And so it also does need to be on a very stable surface, because because what it's doing is it's smoothing subsequent layers of this powder over there, and that powder is in effect a fluid and will be affected by motion. So
excuse me, Thilo.
Yeah.
Are you sharing your screen, or because you're saying?
Oh, duh. Thank you very much.
That's all right.
I'm just, yeah. Let me see. I've been out of academia for long enough that I've forgotten. Okay, come on. Not photos. Yeah. Okay, so this is probably a bit more entertaining than watching me.
All right.
So yeah, thanks for pointing that out. I am a bit harebrained. Okay, and so so the oops. So anyway, yeah. So here are the images, just so that you know, um, and the so just what you see here is a sort of a jumble of shapes and that I'm printing on the printer, and what those are a sort of a fiddle rail for the hard top that I'm going to be building in the next few weeks. And what I discovered in my research is that that fiberglass and epoxy, or fiberglass resin, epoxy resin, sticks absolutely amazingly to nylon, whereas it doesn't stick very well to most other filament materials. And in fact, it sticks better to nylon than it does to wood. So I decided, instead of going through the agony of cutting and shaping the fiddle rail, I have instead decided to just make the profile once and then have print it by section. That's just an example of some of the things that you can do with that. And then here, showing you the resin printer with the upside down monster or whatever that is, and then at the bottom corner here is selective laser sintering, which can print. This is probably a much more complex shape than a block that you see right now, but there is a lot of post treatment that you need to do in that case as well. So those are some ideas of what what the technology is. Now, what can you make? The interesting thing, if it's plastic, chances are you can make it. If it's metal, quite possibly so. And what we've found is that the variety of filament materials and printing techniques has grown exponentially in the last 12 years. In fact, it started its growth period in 2006 because there was an academic research project that, because it was for research and educational purposes only, it wasn't violating any patents, and they never sold any printers. But what they did was they designed an open source, basically a open source version of the Stratasys printer technology. And so that was the beginning of it. Stratasys had very strict rules on what filament could be used in which machines, and how, and they were the sole source. They didn't allow anybody else's filament to be used in their machines. So once people had their own machines, they were able to explore with a variety of filaments. And so in the first few years, there were only really two types of filament. There was PLA, polylactic acetate, and it continues to be one of the mainstream printing materials. But this is for people who want to make little statues, or want to do costumes for their various superhero cosplay things. And so it's a good sturdy material. Technically it's biodegradable, but it also is it absorbs a lot of water. It does absorb water. It can decompose, and it tolerates sunlight okay, but it doesn't tolerate heat very well. So you have to consider some of these things, and I'll talk a bit more about that later on here. But for purposes of being on a boat, anything other than interior things are not going to be suitable to have made out of PLA. And so there are very few reasons that I and very little PLA that I have around. ABS is the same stuff that Lego blocks are made out of. It's a very, very hard material. Anybody who's walked through a playroom and barefoot and stepped on a Lego can attest to that. I certainly can. But it does not handle. It gets very, very brittle in high ultraviolet environments or over long-term exposure, and so it will crack and splinter very easily. So, and the other thing is ABS, when you print with it, it puts out a sort of a caustic type of fumes, which frankly are not very good to be breathing. And so, yeah, I used to print with ABS originally because of the hardness qualities, but it was also a flawed material. Recently, they've come out with PET-G, which is a form of PET, just like what the drinking bottles are made out of. I've found that to be a really amazing material. It is hygraphobic, so it doesn't absorb humidity in liquids. That doesn't change the characteristic of the material. And so there are these things to look at. But now they're even coming out with new ones. Polycarbonate is something that I'm going to look into, because the other day my wife broke this little cover for the refrigerator door. And although you can't really print transparent polycarbonate, the print doesn't come out fully transparent. It does come out to be relatively highly translucent. But the other one that I've seen, and I just have been getting into reading up on the last few days, is ASA. Don't ask me what it stands for, but it is super high strength. It has good durability. It's hygraphobic. It basically does everything. And I'm going to look at things like, I don't know about you guys, but the tailing rings on my 58 Lumar winches, the electric winches, on both sides were damaged when we bought the boat. And I looked at what Lumar wants for these 3 rings and associated springs, and it's ridiculous. I think it was something like 600 euros or something like that. But everything I've seen indicates that this ASA can stand up to the types of stresses that those rings, which are also made out of plastic, are subject to. And so, that's one thing. I'm also looking at the possibility of mocking up the inner gears for the bow thruster, because this material should be able to hold up for that. It's immune to oil. It works well in an oil environment. But they've been making functional gear sets out of nylon for quite a while now. And so these are all things that we see. And the materials science really continues to progress. I just read this morning that made a 3D filament material that absorbs CO2 and CO2 and other gases, in theory, to create a better, more healthy environment. I don't know how much of that is really true or effective, but that's what they're saying. But in addition to just the materials, the filaments themselves being made of different chemical structures, there are also blends. Now, there have been blends from the early days of filament exploration. They would make a blend of PLA and sawdust to create wood. And by printing different layers in at different temperatures, you could actually create an appearance of grain in the wood, because at the higher temperatures, it would sort of toast the wood a bit, and it would make that a bit darker. But so they did wood and stone very early on, and then they got around to adding fiberglass, chopped fiber. Carbon fiber is readily available as a blend of many different plastics. Most commonly, you have nylon, and there's also polycarbonate carbon fiber. Interestingly enough, the ASA material, I just was watching somebody who had done a comparison of ASA versus ASA with carbon fiber, and they found that actually made the ASA less good, but still stronger than anything else, because the carbon fiber made it more brittle. It didn't have quite the elasticity that one would want in that case. And it's not highly elastic, but even so, that without having the ability to give and flex a little bit, just as metal does, it would tend to, it would break more easy, it would shatter. But then there's also Kevlar, aramid blends, things like that have really opened up the things. The other plastic that I failed to put on this page was that of TPU is the common chemical composition of it, but most people just refer to it as flexible filament, because there are different formulations, different hardness, and so that's one of the things that, frankly, I find to be one of the most promising materials for a cruising sailor, because
Tilo, can I ask you a question?
Sure.
Yeah. So for, let's say, the Lumar winches that you were talking about, what would you use there? There you would use the nylon or the polycarbonate?
No, I would use the ASA.
ASA, okay.
And so that one really has, polycarbonate I have to experiment a bit between the two, but frankly, I think ASA is going to be the winner there.
Okay, but that's a softer one, right? And now you were talking also
No. ASA isn't soft. It's about as I was saying, it's about as it's flexible like metal is.
Yeah.
And that metal has the metals we tend to want to use in gear trains, for instance, are not cast metals. They're steels that have a certain amount of flex to them, that prevents them from being so brittle as, for instance, like cast aluminum snaps very easily, and frankly, cast iron also can snap quite easily.
Yeah.
But
So, but then and then for the bow thruster gears, you would also use that or something else?
I'm considering, I'm looking at at basically a carbon fiber nylon blend. That would be, that's a good application for that, because you know nylon doesn't mind being in oil at all, and it never has any UV to it. So that's a pretty ideal application. Nylon is while it is not, it's not soft by any means of it. It's it is it has more flex to it, and so it's been used for for gear trains for a long time now, for a number of years that they've been making nylon gears, and so those are the things that we're seeing, and that's why I think, frankly, the question is, can these gears hold up to the real burst, the initial burst of power? But then again, if you look, I mean, the propeller nuts are made of either palm or nylon, but they're made of a nylon-like material.
Yeah, the same with the shaft. The shaft of the bow
Yeah.
thruster is also nylon.
Yeah. So I think, I think it's wonderful that these things are available, and that it is doable in that sense. And here is the possibility that, if we, on the side here, the image that I'm showing here is of a, something I just looked up the other day because I have a sous vide cooker and the stupid bracket has cracked. And so I went onto this site, Yegi, which is an agglomerate, or it searches all of the other sites that have collections of 3D models. And so I just punched in ANOVA sous vide and came up with all of these things. And of course, what are the most common things that you see here? They are the very bracket, that this thing right here, and this, and then there's this. All this is the thing that has, oops, wait, touchy mouse, that I've basically been, that I need. And so other people have also found this need. So there are plenty of sources out there. And these basically you don't pay for, you just, you can download their shareware, you have the option to contribute if you want. But these are the real, this is the beginner's way into the market. You're able to, search for what you need, and then go from there. So, that's just an easy way to get in, and then you can experiment with your own materials, all the other things that are part of the printing process. So, did someone have a question there?
No, it was
okay.
It was Els that sneezed.
Okay. Okay, good. So, this is just, an overview of what's there, and what Bill and I have been talking about is actually creating a file section on the owner's website that is dedicated to just 3D models, and that way, because we all have the same problems. You know, this is the wonder of the standardization of the AMLs, and so I think that that is, you know, where we can really contribute with things like, yeah, I mean, I have no problem putting the, you know, the hatch hold open, things that the port light hold open things, or simple stuff in there. So these are all the, you know, the possibilities that you have, and I think that if we all sort of chip in, then we'll end up with quite a library of things that will allow people to basically be wherever in the world, download a relatively small file, and then, you know, print what you need. So you know, this could put an end to a variety of the issues of trying to, you know, get something shipped to someplace in the South Pacific or anything like that. I mean, this is the real potential that we have here, and so that's why I think that it's worth talking about this stuff in more detail. So that just gives you an overview of sort of where you can go with it, and then I'll, you know, I have some things about what to look for, and this is, you know, essentially it was my criteria, or my, you know, led to my criteria for what I needed. So what do you anticipate you'll print? Now, in my case, I knew that I was going to be printing flexibles, and flexibles want to be pulled, not pushed. There are two types of extruder mechanisms. One is called a Bowden drive, which is basically at the filament spool, and it pushes it into a tube that then leads up and over the printer, and then to the print head where it's squeezed out the nozzle. But soft, you know, it's, as we say, it's like pushing a rope. The more flexible your material is, the more resistant it has to being pushed. And so the other type of extruder is a direct drive extruder, where the gears that sort of push the filament through are directly on the print head itself, and that pulls that filament. And there's still some things you need to watch out for, but it's a much better solution in the printing realm. Now, so that talks about what you'll anticipate to print. The other thing is, if you want to print with these, with the more advanced filaments like the ASA and even nylon, you need a printer that can print at higher temperatures. Many printers are not designed, you know, they're designed for hobby printers who are printing stuff out of PLA, which requires relatively low temperatures. But what we want is, you know, we want to print items that can withstand being out in the sun in the tropics. And so that's the primary reason why PLA just doesn't exist in most things that I think of printing. And so there you need to make sure that you have a printer that is capable of going up to 300, 310 degrees nozzle temperature, and the bed can go up to 110, 120 degrees to, you know, to keep things really warm. And so these are the things that you need to look at. And you also need to think, how big will these things be? I actually, because my first interest was printing screen frames. I needed a printer that could go larger than 39 centimeters, or about, 30, it's roughly 39, somewhere around there. And so I bought a 40 by 40 centimeter build plate model. And so, but then I realized, yes, I mean, it's great when you're printing big stuff, but it takes a lot of space, and it takes a lot longer to heat up. It takes a lot longer, it takes more energy to print, because it can't just heat up one section of the platform. It has to heat the entire platform. And because of that, the thing, I find I can get smaller jobs done much more quickly and much more efficiently using a smaller one. So then I bought also one that's about that's a 23 centimeter square build plate. And that one is my everyday source. So, and then you have to think, of course, when you're thinking about, okay, I've got this big thing to make, I could have actually made the screen frames on the smaller printer. What I would just have to do is I would have to create, basically a notching or interlocking system for the frame pieces, which I will have to do anyway for the design that I'm working out right now, which is for the main hatches, the big hatches overhead. All the hatches will be larger than my build volume, so I'll actually need to build each frame in orders, and then just have it so that they overlap and interlock when they're screwed together. So be willing to think about how you can adapt. That is something that that you can factor in there. And then what space can you allocate? Because when the machines in general are very big. I mean, my previous 3D printer was in a plexiglass enclosure that was a rectangular cube, if you will, that although it had a very small build volume, it was a big inflexible piece of machinery to have around. So so keep that in mind. How can you deal with the amount of space these things take? And then also consider, what can you do when it all goes wrong? Because these are still machines, and I seem to have a bit of a problem with machines that I purchase that turn out to be just oddballs. Right now I have a Dometic refrigerator, which I'm taking back to Italy for the second repair of the same problem. And also the large 3D printer that I got has just been, it's been non-functional for far too long. And I'm now talking with the warranty department about just getting the thing replaced. But I've talked to many other owners of the exact same printer who say, no, it generally runs fine. And of course, sometimes you need to adjust things or replace belts. And so that is, that's enough for me to say, okay, I'll be fine getting that one replaced. And the ease of working on them, because I've read about other manufacturers' machines than the one I have that people say, well, in order to get at this part, I had to dismantle half of the machine. And so I looked for something that had a good serviceability. And what I came down to for my criteria were that I needed a direct drive extruder that had the capability to get up to the higher temperatures, and that could be easily put together and dismantled, and therefore would use much less space and could be stowed away more easily. And so in my case, I bought two because I have ambitions of doing really large projects, some of which can't easily be interlocked. And so I'd rather just have a big build space. And, and the nice thing about the fact that I bought two printers from the same manufacturer, and I made sure that the two printers had a very large overlap in parts, common parts. So I don't, yes, because of the size, some of the things like the belts and other things need to be different, but by and large, a lot of the parts are interchangeable. So that means that with one parts kit, I can pretty much address all problems, and that way, I will be able to continue printing no matter where I am. So what I ended up choosing was the Mingda Magician series. And it's got a direct drive extruder. It's easy to assemble, and it uses an established technology that has tried and true common parts. It does, they recently upgraded them to be able to print at high temperature using an all metal hot end. So, and they've got decent parts availability. Now, today I actually set up my small printer, and so I did a time lapse video of it, and it took me less than 4 minutes, I think, or about 4 minutes to put it together. And then on the right hand side, you can see the large printer, which is unfortunately not working right now. But you see, it's I've pretty much got it all wired up and assembled. Yeah. And yeah, there you go. Bam. Somebody have a question or comment?
No, I just put my thumb up. Good job.
Yeah, but this is the amazing thing, because then I saw,
Yeah. Is this the small one, the one that you were talking about?
That's the small one. Mm-hmm. But the large one, they have three sizes. So I have the smallest and the largest. And there's also one that has a 30 by 30 centimeter build volume, and which ironically is called the Max. They're all Magician, but then there's the X, the Max, and the Pro. So I have the X and the Pro, but I can tell you the X that I had, and this is the thing, is that the Pro has been nothing but an ongoing nightmare for me. I've pretty much replaced most of the parts. I had to argue with the service department about them sending me a new motherboard to the printer, because I knew from day one that it was fried, but they made me test it interminably. And so but on the contrary, at the same time, I've been using the X pretty much nonstop, and it's just been wonderful all the time. Not a problem at all. So I know that it's not about the overall technology or the quality of build or anything like that. It's just that sometimes you get a lemon. So so I've been really pleased with this printer. And right now I'm in Port St. Louis. That's a 5.5, 7.5 hour drive from my two apartments, and so I travel back and forth with both these printers, and they've stood up really well. And the printers themselves don't care if there's a little bit of rocking and rolling. The thing that when they talk about leveling the bed, this is leveling the geometry within the printer, letting the print head know exactly how far away from the bed it is. And these machines are really stiff and sturdy, and so it's not like a little bit of wobbling is going to cause error in the printing. So
with this X, Tilo, with this X, you can make these window screens and the
no,
Batterie naman plus nou geen. Pistof mimla WLAN. Signaal timmer.
The X is a 20 by 26, 20 by 20 by, or no, 230 by 230 by 2260 millimeter build volume. So, I'm printing the perimeter of my hardtop in 25.7 millimeter or centimeter lengths, and so that's just making it really, adapting to that. I could have tried doing it on the Pro if it had been working, but I also realized that printing very relatively narrow and long, columns on a printer, which the bed moves around, and because of that, that sort of rattling will end up knocking the prints over. And so at a certain point, printing a longer piece doesn't really help. So I've been happy with doing these out of nylon, and I really surprised a number of people in the community, in the printing community, with that. But these are really good printers, and so that's my opinion. I looked at all of them, and the only one that the one that I would have also considered had the same build volume, but the overall structure of it was larger, and so it would take more space to stow it. So this is a very compact design that fits together very nicely as a broken down unit, and therefore can be stowed in relatively little space. So I think, frankly, that the X is good for the majority of needs. Now, yeah, things like the window frames, then I could, I'd have to then make those in pieces that would somehow interlock, and then either mechanically join them or bond them in some way.
So the window screens you made on the Max?
I made, on the Pro.
On the Pro.
Yeah. And so that's because these are 39, the port lights are 39, but I won't be able to make the hatch screens out of that because or I won't be able to make them as a single unit. I'll have to make them basically in quarters of uneven lengths, so that basically, you know, it should be that I just have to design one piece that then you
Overlap.
clip and you overlap and you know, long edge, short edge, long edge type of thing, in order to create, well, at least for the 50 millimeter hatches. Now the other ones are going to be a bit more tricky, just because of the fact that they're not symmetrical. So yeah, those are the things that I'm looking at. Yeah, and so I wanted to then show you.
Thilo, I have a question about, maybe I didn't understood correctly in the beginning. For some application or some material, it's not possible to print on a boat because it's moving.
Yeah,
so
those are the resin printers, and so it's the basically this is why, you know, most people are fixated with the fused filament technology. It's easy, it's accessible. It does not require you know, having highly stabilized supports for the machines. It doesn't you know, it doesn't require special ventilation, except if you're printing with ABS. All in all, these printers allow you to print pretty much everything on a boat.
but sintering or metal is a powder, so that is probably not usable on a boat then.
That's not, because it's such a fine powder that it has fluid qualities, and so that won't work. And for the same reason that the resin printers also won't work. But yeah, and resin printers have a generally a very small build volume, and so that's also an issue. There are basically, I mean, I think they make one type of 3D printer now that is a conveyor printer, and so you can build exceptionally long but generally narrow items on that, because it has a conveyor belt that will shift the printer back and forth, or the print back and forth. But
so okay, thank you. So for a liveaboard, it will be limited possibility to go. So for full time, it's probably do it somewhere at home and then bring to the boat.
Well, if you're using resin, or if you want to do resin printing or SLA, SLS, yes. But for what I'm talking about here, there's no problem. You know, for the filament type of printing, there is absolutely nothing stopping you from doing it on a boat. And for you know, by and large, for the things that, for the majority of things that we need, you know, the X or maybe the Max would be good enough. You know, in my situation, I just knew that it would take a bit more for what I wanted to proceed with. So this type of printing, the filament printing, is just not any problem. And you know, you basically buy filament in 1 kilogram rolls Oh, yeah, I actually got uh, got pause my sharing here. So, I got one today, which is
Okay.
this is this is just a filament roll. It's 1 kilogram of 1.75 millimeter filament. And this is a PET G that's in white. So it's very durable in the outdoors. It doesn't react, it's very stable in UV. It makes, and it makes very dependable, good prints. So that is the type of thing that we are, that you deal with.
And what's the cost of such a roll, Tilo?
This cost me 19 euros on Amazon.
Wow, that's good.
Oh, sounds great. Thank you, Tilo.
Yeah. So, I mean, I have a relatively large library of filaments. I'm generally streamlining some of them, knowing that I just need to get rid of some really old ones that don't fit my needs in this environment. But I mean, that's the thing, is that this, I actually had bought in 2012, I bought a spool of nylon filament. And because I was, I found out, oh, wow, I can do these the fiddles for my hardtop out of nylon. I pulled that out and it printed just fine. So an 11-year-old roll of filament doesn't have a problem. It's not like it has a use by date. And that's what is, so it's not a perishable consumable. If you have, one roll, and one roll will go quite a long way, because, an example here's one of these profiles that I built, and you can see here, this is the profile of that. This is printed effectively. It's got basically one thickness of the wall. So this wall, which has quite a nice finish to it, actually, has one thickness, and it has I think 5% or 7% infill in here. And so, and that also is just one wall thickness. And that's why you see this pattern design, that this is the infill pattern. Now, I can make it flex, but for something that is effectively, that's effectively, I'm putting a couple of kilos of force on this, and this is really paper thin. All of the elements are paper thin, but you can see that this is, in itself durable. If I wanted to make it a bit more firm, because of the type of infill I used, I could put a 2-part expanding foam in here, and it will drain all the way down to the bottom before or by the time it starts expanding. And so it'll expand out through this infill to fill the whole thing, and that would make it much more rigid. This is a type of thing where you can use it in a very structural manner. So these are the types of things that you can do, and then, what I'm also working on, because our lampshades are trash. Jeanette wanted to do, she wants to do a, recover them in some sense. But what I've gotten here, this is a PLA filament, and it's called a pearl filament because it does have a certain amount of luster of pearl. And then, this will be in a, where's my third one? Oh yeah, there's my third one. This will have the same sort of scope, but just basically be an assembly like this that attaches to the existing light stanchions. So, that'll be pretty neat.
We had them redone with silk.
Yeah, so this will cost me next to nothing. And so it's much simpler. But yeah, that's something that, and this material has much more of a luster to it that'll make it very interesting. One of the techniques that's also coming into mode is lithography, where you can take an image and then print something like a lampshade, but with different thicknesses in there, so that it will have a, it will sort of show in the lampshade the image that you choose. One thing I had thought about was making Amel lampshades that would fit on the existing lamps, that have the Amel logo on them, or a sort of a good picture of a Super Maramu, under sail. So these are the things that you can think about. So, and then I'm going to go back to my screen sharing, because I wanted to show you, which one? Yeah. Going to show you what my newest project is. And, wait, didn't. Yeah, there we go. This is my first functional prototype, and this is this now makes the pilot berth area the coolest place in the boat, because these three fans move a huge amount of air, and they're pulse width modulated, so if I have them on the lowest the lowest setting, they are absolutely silent, and they still pump a fair amount of air, but they don't use much electricity at all, because pulse width modulation, instead of burning the excess electricity through a resistor, what it does is it only feeds pulses of the correct voltage out to accommodate the speed that you want to attain. So I'm starting production on these things. Anybody who wants these, I'm going to be selling those.
Can we place the order now?
Yeah. Yeah, I think I'll probably put something up on the I'll put out an email on the group site explaining things more clearly. But yeah, I'll be taking an order book on that. I've already got 6 people who've insisted they want them, and it's really a game changer. Certainly in the the pilot berth area. That I tell you that I can't believe it, because we all have said that's the hottest area of the boat, and I just now if I want to cool off, I just go sit in there. So it's really amazing, and I've gotten the quietest, highest volume, lowest energy fans for these. So it's made with and made with this in mind, and it plugs into the light circuit for the fuel gauge. really easily. And it just occurred to me that this can also work in the aft cabin port light that goes into the cockpit by tying into the dome light that's above, pretty much right above that. So
They're all the same size, right?
Yep, identical size.
Yeah.
Right now, I've got a screen in there that is, at least it's very nice because of the Camargue Air Force that we deal with here. I'm at Port Navy Service. Don't know how many of you have been there, but the mosquitoes are quite voracious. But yeah, these are the things that I'm working on, and yeah, I'm setting up to do full production. So I just today bought a second printer, so that's what I'm doing. Okay, and yeah, so that is that's what I wanted to talk about today, and then in our
Elon?
next meeting. Yeah, go ahead, Bill.
Yeah, I want to jump in right here. Why don't you combine the screen and the fans?
Oh, there will be. That will have a screen in it.
Oh, okay.
Absolutely.
Yeah.
And I've got that one set up so that there's so that the all of these have some sort of a flexible component to it that acts as a gasket. And then they have I also have tabs on them so that in case somebody, they're tabs that will swing out so that in case somebody bumps it from the cockpit side, it doesn't get thrown across the pilot berth. Because I had that happen once, that I just bumped it and it went tumbling. So I've done a lot of beta testing on it, and I'm now, if I can just get my printers working, I'm going to be in good shape. And I'm going to start production.
One of the things you need to do, that that port light is the same size on most boats. It's the same size on the Super Maramu and on the 54. I'm not sure about the 55, but I think it might be. And of course, the Maramu has a bigger one, a bigger port light there. So what you need to do when you get started, be sure and give everybody the dimensions of the port light, just to make sure that somebody doesn't order the wrong one.
Yeah, because my idea is to continue to expand on this and expand to different size port lights. But yeah, that's really the idea. I'm even thinking about for the head, the aft head, and for the galley, doing one that has also a sort of a rain hood that drip hood, rain hood that will that's really that will work better and allow you to leave the hatch open in mild rainy weather. So we've got a couple of other people who have questions here. So who had, okay, so let's see, I'm sorry, the name.
Jose Benitez?
Jose. Yeah, hey, great hearing from you.
How are you, Taylor? Good to see you too. Thank you.
Good seeing you.
Yeah, I missed the first 4 minutes, so I don't know if I missed the place where you mentioned what kind of software are you using to create the drawings before you put them on the.
Yeah, this is actually going to be part of a further workshop. I didn't want to load people down with too much in the way of specifics. I already got a bit scary about talking about the different types of materials, but the anyway, the software that I use for creating my my stuff is a program called Shaper 3D, and I think I may be able to. Let me see if I can. Why is it not? Let me see if I can get this. So let me, I think I can share my, wait a minute.
Yeah.
I'm not. I can do this here. Let me just put a cable in, and then I don't have to worry about
that would be all right, Teal. If you can just put it on when you
Yeah.
also describe the others, that would be great to look at what
Mhm.
I've heard that they're now easy to use programs that can very much easier than the 3D
Mhm.
CAD programs that I remember ever used before.
Yeah.
So that would be wonderful.
Yeah. So I found Simplify 3D to be just amazing, and it doesn't take much to really get into it. And yeah, it doesn't want to. Well, okay, it's not wanting to do that. So never mind with the screen sharing. I'll be talking about that in more detail in the third version of this. And depending on what interval we want to be looking at. So my idea is that by the next time I'm going to do some practice printing with the more technical materials. So one thing that I've already designed is the ballooner de-hooker mouse, and that I'm thinking of doing in a polycarbonate carbon fiber blend, so it should be just strong as nails. And having all of these designs on hand could be invaluable for our our people. Now, so Eric, no, yeah, yeah, else, you had the question.
Yeah, I actually had the same question. What kind of software do you use? Because I'm used to use AutoCAD 3D, but I don't know if it converts to the printers.
It does. I mean, that you can export it as an SLT file format, and that's what there's a 3-step process of this, and there's an intermediate step after you've designed the article or after you've downloaded an existing model, that you then have to feed it through a slicer, because what you get in the form of a 3D file is a description of a solid object. And then what you do is you have a slicer that has the profile of your printer, so it knows what instruction sets to give, and it also has all of the things from you about what type of filament you're using, what temperature you want to print at, and all sorts of things. And so that is what then creates a file that's a G code instruction set that you then plug into the printer. And there are several slicers. And I had been using for the longest time Simplify 3D. Causes me to get so the 3D modeling program that I said is That's Shaper 3D, pardon me, without an E in it. But Simplify 3D is a long-standing commercial software, slicer software that tends to be a bit higher end. But there's also Cura, which is a slicing software that is more or less open source. There's Prusa Slicer. There are a couple of other ones. More or less, they all do the same thing. It's just, what kind of interface you feel like dealing with, how detailed you want to get, and all of those things. During my fight with my interactions with the service department, they insisted that they've only tested their stuff, their printers using Cura. And so I was ultimately forced to learn Cura. And yeah, now I tend to use that as my go-to. So that's a really, nice thing. Yeah, I was just seeing here. When I replaced the acrylic in our hatches, the handles are all in good shape. The only thing that was torn up are the O-rings. But Goyo uses an O-ring that nobody carries. I couldn't find it anywhere. So I have a very soft material, and I printed the O-rings. That just took me a little while to do, and because generally O-rings only have to have 2 smooth faces, and the printer does a good job on that. And admittedly, the other round faces aren't that great, but it works just fine. I've had a few real downpours here, no problem with that. So this is just an idea, and I had also a neighbor here who came and said he was having trouble with the flapper valve in his bilge pump, that it was 6 months old and was curling up. And so I was able to, within 45 minutes, design, measure out and design design exactly that. I printed it first out of a bit of a more rigid, flexible material. And but then I reprinted it eventually in a material that has a hardness of 70A, which is basically the general standard for O-rings and gaskets. Yeah. So yeah, next question.
The other question was do you get any software with the Mingda magician eggs, or
they send the Cura software on it, but it's better to download directly, a direct update of Cura. It's, doesn't cost them anything, and it certainly doesn't cost anything to go online and get it. And so that works just fine. But yeah, there's no, the printer has its own interface, but these interfaces are relatively standard anyway.
It's a driver, yeah.
Yeah. Mm-hmm.
And what is the power usage of these printers? The small one we're talking about.
The small one, the heater is, of course, it depends on the environment. Right now, I have the forward cabin somewhat shut off, and it's relatively warm, so that the heater isn't there's the bed heater, which is heating it to 60 degrees, I think. No, 80 degrees. So that's a bit warm. And the nozzle is heating to 263 degrees. Oh. But that's just a little metal nozzle. Now, they've also started putting, that printer has around the heating block that the nozzle comes out of, and it's actually the heating element that's in there. They have a silicone sock that fits over that, and that helps to prevent, that helps to sort of keep heat inside. It acts as an insulator. So and then it is also possible to have an enclosure. Now I do have an enclosure that can be taken apart and rolled up. It's basically a tent type of thing with zippers and stuff. And especially in winter time, pulling that out and putting it up and putting the printer inside of there keeps that environment much, much warmer, and thus takes less heat, and it results in more stability in the print environment.
Okay, but are we talking about 5 amps or 10 amps or?
Probably, yeah. I mean, I think it's not even 5 amps. What is my? I mean, I think I'm pulling 1.3 amps right now, and I've got the Mingda printing. I've got the X printing, and I also have a powered cooler running constantly. So it's not even 5 amps. We're talking about very small.
Oh, that's little.
Yeah. So, I mean, it might draw a bit more when it's heating up, but I don't think it's going to go above an amp.
The freezer takes a lot more.
Yeah. So I think that, and of course these are AC driven, and it'd be great if we could actually just run them directly on 24 volts. But because I believe most of the components in there are 24 volts. So it's nuts. But no, the printers, they're not a huge power draw. They don't cause anybody any problems. It's not like the boat browns out when I plug the thing in, so you don't notice it.
Right.
Mm-hmm. Yeah. So, Bill?
Yeah, are you close to finishing?
Yeah. I think that as long as there are no more questions, I'm pretty much done. So thank you everybody very much. Thank you, Bill.
Let me say something. Can I say something first before you say that? When Tilo and I talked about this about I guess 6 weeks ago, the first time, or maybe even 2 months ago, Tilo's vision and mine also was to have a repository of these files in the group. To me, that makes this so much easier if we have 30, 40, 100 people contributing files for various different things that we need, such as the little O-ring for the hatch to keep it from leaking water, right? Mm-hmm. So that was his vision, and he said to me that when he got started, he hadn't really ever used CAD before, and he found this software very friendly to him, and he was able to get to a higher level of use of the 3D printer than he ever envisioned. So this, I believe, is the first of 3 sessions that we talked about. Is that right? Okay. Mm-hmm. And he's going to get deeper and deeper into the 3D printing in the following sessions. I don't know about you guys, but I'd like to see the following sessions sooner rather than later. And so maybe, Tilo, it's up to you, because I know it's your time frame, but maybe we could do it sooner rather than later.
Yeah,
next one in weeks rather than months or
sure.
days.
Yeah, no,
probably weeks.
I'd say, maybe give it 2 weeks. I was also thinking that, it may be possible to do one session for, or a workshop for those people who decide to buy a printer. And, in which case there is, I could do a, getting started with your printer, talking about setting up and what the functions are. So really something that's a very hands-on, discussion about the printer itself.
Yeah. Yeah.
So if people would like that, then we can do that as an additional session.
Maybe a fourth session, then the last
Mhm.
one sitting down actually doing it with you online.
Well, I mean, it actually depends, because if there are a few people who are going to now run out and get a printer on my sketchy recommendation, but if they were going to do that, then I'd be happy to sort of show them the nuts and bolts and how to get started and what some of the common pitfalls are.
Well, Tilo, I think I'm speaking for everybody. I really appreciate the time that you put in this. I appreciate you sharing what you've discovered, and I look forward to the next thing, which will be
Mhm.
a repository of these files. I think we can set up a
Mhm.
folder for
Yeah.
these file section
Yeah.
on the ML owners group. Be really easy to do, I think. So,
Mhm.
and maybe, Tilo, what we might want to do is pick a couple of the ones that you've done and put them up there
Yeah.
sooner rather than later.
I can start populating it with like the O-ring and the flapper valve and stuff like that.
The simple stuff. Well, look, that
Mhm.
flapper valve that you're talking about, every ML owner, whether it's a 50, a 55, a 54, a Super Maramu, a Centurin, almost everyone, if they have the original bilge pump, they need a source for those flapper valves, or they need to go out and spend €850 on a new Plastimo pump. So the pump that they have was made by one of three manufacturers. It changed over time, but they're all the same. They all have the same internal parts. And regrettably, I don't know if you guys know this, but regrettably, when the last company that made that pump, TF, as in Tom Frank, TF pumps in Italy, when they made that bilge pump, they turned some of the parts manufacturing over to someone in China who made some really bad flapper valves. And, I've heard owners speak of that. Oh, I got new ones from Amel and they lasted 3 months, right? So it wasn't Amel's fault. It was PF pumps turning it over to some guy in China that made them look exactly like the original. That was a keyword, look exactly like the original. So anyway, I want to thank you again for doing this. I'm sorry I was late. I had the wrong time, I guess. I thought we were starting at 2000 UTC. So I apologize for that. No, you were already going when I came on at 20 minutes before.
No, well, I posted it as 20 UTC, but
maybe my time is wrong here. But I apologize. Sorry.
Yeah.
So thanks a lot.
Okay, great then. Yeah, so we'll see about setting up. What I'd like to do is in about 2 weeks would be good for me, because I'd like to do some further fooling around with these materials and maybe even get around to popping the tailing rings off of my Lumar and seeing about making modeling those up and seeing if I can do a test on that. That would just be to me, that's a vengeance thing. To not have to pay the usurious prices that Lumar is asking.
Yeah. Do you think you could 3D print some euros for me?
Uh-huh. No,
Or
I
dollars?
can't.
Dollars.
Yeah, no, it doesn't work that well. So
Okay.
yeah.
Mm.
So great then. I really appreciate the interaction that you guys had. And if you're interested, I'm always here. You can always mail me. And I will be putting out an announcement about the companion or the pilot berth / owner's cabin fan.
Yeah, anything you're going to do like that, please post it on the ML owners group. I know it's, in a way, it's sort of a commercial venture, but forget about all of that BS. It's important for the owners to be able to have that. So be sure and put that on there.
I will. Yeah, I'll announce that. And so, yeah, it's that's good then. Well, and I'll keep you updated on my other designs. Yes. Uh-huh.
As Bill, I was wrong with the timing, and I arrived. I thought I was 4 minutes late, but obviously it was much more than that when I came in. Yeah, I read 16 hours, and that's when it was 16 hours in Boston, but it may have been 16 hours. Anyway, it doesn't matter.
Okay.
One quick question: where are you keeping this thing? Is it in the forward cabin on the little table? Is that the size that it
the X, the smaller one, fits wonderfully on that table. It also has it has room for the filament dryer that I keep behind it, and so that works out wonderfully. And then the big one I have sitting down on what would be the bunk, and so that works just fine. By the way, one thing you guys didn't ask about, and I don't know if you've also been sort of lurking on the net while I was talking, the X costs about 200 euros, and the Pro is 600. So, compared to the printer I got, 12 years ago or something, which I paid just over 1,000 for, and it was the cheapest printer on the market at the time. And it had just only a shadow of the type of technology. So, and I know that I know that Mingde even has some printers that are Amazon returns or things like that. They're selling for 89 euros. So it's really not a costly venture to get into. This is very simple and very inexpensive, relatively speaking.
And they're running at 240?
Yeah. Yeah. So it's actually, I think it comes with a universal power supply, but yeah, they're running off of shore power right now, so it works fine.
What's the difference between the X and the X2?
Not much. I don't quite understand what the difference is. They've put an additional fan on there. I'm not tremendously excited about it because I actually just printed a new housing or cover for the print head that has the bracket for the fan, and so even though my X was not designed to have two fans, the Max and the Pro always had dual part cooling fans, and they, so I can buy the fans pre-wired for the dual compatibility. In fact, they only sell the ones that have a branching connector, and so I don't see the real difference between the two, and I don't think it's really worth going that way. And the 2X also has some different part numbers. So the interchangeability of those is not ideal if you're having more than one. So but it's not a matter if you're only going to be using that one, one printer. So it's a matter of choice at that point.
All right.
Okay, thank you, Tilo.
Thank you. Tilo.
Okay. Thanks
you
a lot,
very much.
everybody.
Great. Thanks a
Okay.
lot.
All right,
Bye-bye.
bye.
Yeah, so that's the way it goes. So, Eric, what do you think? Are you going to
Well, I mean, I'm really looking into it now because you gave